So hi everyone, I'd like to introduce you to our real-time visual card reader for mobile devices. But first, I'll go to introduce you to loyalty cards. Because currently more than 280 US chains already offer loyalty cards. And you can use those cards at checkout to collect points and later redeem rewards. But if you are a customer of just a subset of those stores, you're going to have a difficult time carrying all those cards, right? Because you'd need a pretty huge wallet. And currently, everybody has a mobile smartphone, or most people have a mobile smartphone. And there are a number of apps that allow you to just scan your card and carry them digitally. But for cards where you don't have a barcode, currently you have to enter all this data manually, like enter your customer number and the card type. So our goal is to create a system that automatically extracts all that relevant information from the picture of a loyalty card. And then you get the provider, the card type, and the customer number, which basically is a constrained OCR problem. And OCR is considered a solved problem at this point, but we tested it with a lot of software that does OCR on smartphones. We used Tesseract, a full-blown OCR engine. We tested 2 OCR apps from Google in the area of scene text detection and a special app that is a business card reader and a credit card reader. But actually we found that our current problem is a very tough problem and far from solved, because the best app, which were the apps from Google, only extract 45% correctly. And the special credit card reader doesn't solve a single sample. So probably they encode a lot of domain knowledge that they implicitly encode in the algorithms and cannot cope with our data. So what actually makes loyalty cards difficult? And there are 2 main reasons we identified. First, we have a huge variety of colors in backgrounds and fonts. And mostly those colors are not selected for readability, but for like corporate identity reasons. They have to look nice and use the corporate colors. And also what we have is a pseudo-random sequence of characters. And most approaches out there that do text extraction in the wild, they use a dictionary, which makes it pretty easy, because if you just detect a few characters correctly, you can guess which the word is. But in our case, if one character is misdetected, so we get a different character or non-character, the entire customer number becomes invalid and we cannot reconstruct it. And that makes our problem difficult. So what our approach does is we use the input image, and in a first step we use a classifier based on a bag of words of card key points, and then identify the exact card type and provider. And now that we know that, we can, for each succeeding step, encode knowledge that we have about this card and train each step for this exact card type. So for the component detection, we can optimize the parameters of MECR or CSER algorithms, and then we can use different grouping algorithms, optimize the parameters there, and then hand binary images to Tesseract for character recognition. We combine the resulting strings, do some post-processing, and filter the candidates based on what we know how the customer number should look like length and allowed characters. And as a result, we are able to outperform all existing approaches and solve 70% correctly. But still, for a bit less than a third of the cards, we can't help the user right now. And there still is some open research, and OCR is far from solved. So, as a conclusion, I'd like to show you our application. And you put your card in front of the camera, press the Scan Now button, wait a short amount of time, and you find the final results on your screen. We normalize the image for you, we extract the customer number, and present card provider and card type.